my name is Ecem Şimşek, and this is my project for our digital design course in EE, and its code is 102. And in my project, I create the system in order to receive sound data, record sound data, and as well as display the sound data using an LCD display screen, which is the liquid crystal display. And to begin my project, I first used the PMod Mic 3 module of Digilent, and this module enabled me to actually get the sound data from the environment in an analog format, and to transform this data into a digital one, exactly into 12 bits, using its analog to digital converter. And this enabled me to get the sound signals that I need to use in my project. And once this operation was done in the system, I needed to transfer these digital information into my basis tree board in order to send it to the display screen and also to record it in a memory. And in order to do this, I used a protocol, a communication protocol named SPI. And SPI refers to a serial peripheral interface. And as it can be understood from its name, this protocol creates a serial communication between the two devices. And it creates this communication by using only 4 ports. And 2 of these ports are for the data transmission. They are the data transmission lines. And one of them is MISO, referring to master in slave out, and the other one is MOSI, which is the master out slave in. And it has 2 other ports. One of the ports is SS, and this is the slave select port. It chooses the device with which the master will communicate, and it is also useful for the situations when there is more than one slaves, but in this one, since it has one slave, it is directly connected to it. And the other port is the most important one. It is the serial clock port. And it actually creates the clock signal between the 2 devices. And by doing this, it syncs the 2 devices so that a healthy communication between them occurs. And in the SPI communication, the device that creates this clock signal is called the master, and the one who receives it is called the slave. And also, just for the PMod Mic 3 module, the communication actually occurred in 16 bits by also putting the data into a data buffer and then receiving it. My code had 4 states in order to do this. First, the enabling the communication between them. Second one, loading the data. Third one, setting the data, setting the output. And the fourth one, getting ready and enabling the ready signal. And these actually in the 16 bits, the first 4 bits were the 0 bits, and they were sent at the beginning. And the later on 12 bits were the actual data signals, actual data bits, and I received these data signals once actually at the falling edge of the clock signal, and exactly at the 16 clock cycles. And once I got this data into my system, I stored it inside a RAM that I created, and this RAM was a memory that had 128 times 12 bits, which meant that it had 128 places in which it stored the information in form of 12 bits information. And this memory had actually the write mode and the read mode. And in the write mode, I was able to write data into my memory, and from the read mode, I was able to get the data out of my system. And also it had addresses and I also enabled these addresses by using my switches. And for example, each time I create an address, I actually store it in that specific one. And then by getting the data out of the RAM, by using the read one, using the data output part of it, I had to transfer this data into my Arduino, And I did this by once again writing an SPI protocol. And this time in the SPI protocol, the basis tree was sending out the information and Arduino was getting this information. And once again, it had, for example, enable inputs in order to start the communication between the two devices, as well as having a reset one in order to reset the communication and actually stop it now from recording it. And in my Arduino, I also wrote a code in order to get this information from the basis tree, its own SPI code. Now Arduino was in the form of a slave, and I created an array inside the Arduino in order to store this information. But array has only 1 bit, so it stores it by creating a loop, and it actually renews the data once new data has been received. And I also connected the LCD display screen to my Arduino in order to operate it and in order to get it power supply. And the schematic of my system can be seen on the screen of the computer. And as it can be seen, there is the PMOD Mic 3 module from which the data enters. It goes into the memory RAM in order to be stored in there. And it also has the second SPI in order to send the data into the Arduino device. And the screen of my LCD can be seen here. At the first, it only has words representing the sound data. And once I actually activate the system, it will print the data, the sound data, in the form of integers, which once again I implemented using my Arduino code. And now I can actually display a small demo of my system. And in order to do this, I will do it with using the Arduino, and also in order to ensure the system, I used also a COM5 serial monitor in order to display the data, in order to be sure that it actually goes there. And now I can actually start my system. And in order to do this, I will play music into my system and record it as it is doing it. So I will start giving out the music. But at the moment, it does not record anything as enable is not opened. And now I will enable my system. And as it can be seen, the data is displayed on the screen once it continues to receive music. And also these different data can be seen on the monitor here. And it can be seen that there are some negative information here, but it only represents that there was a sign bit at the beginning of the digital data that was received. And I also display the writing that shows received 12-bit data item from master. And this was my overall project I created for my digital design course. Thank you for listening.